The only thing that we got left to do is we want to create a support structure underneath this part. Currently we have the part centered in the Z and in the X and the Y. So we have a cool command in 2016 that allows you to create a support structure automatically for your parts. Go on the 3D Print tab, pick the support generation command, select your mesh, and you will see down here, now there's quite a few commands and options in the support generation command, and on the first tab, the parameters tab, I think what might help you understand what these parameters mean is let's pick the little help icon here and display the help for this command. Let's scroll down, and what this command does is it's going to generically create a support structure that goes from the base of your overhang on your part down to the printer bed, and it's going to generate this automatically. It's going to figure out how it's going to get from your mesh to the bed based on these parameters. Now if you look at this example here in this illustration, it gives you an indication of what these parameters mean. Now I'm not going to list each parameter. As I said, you can pause the video and you can duplicate these parameters in your part file when you go through the tutorial. But basically we'll just discuss them a little bit. We have an overhang angle, and what that is going to do is it's going to calculate where the overhang angles are on your part. So we're going to set it to 45 degrees. And then you can also set a minimum overhang height. In other words, how high can the overhang be? So we'll set that to 0.25. And then the max angle that the overhang can be that will generate a support structure will be 45 degrees. Let's display this help file again here. And then for the support diameter, that is the diameter of the support structure that's going to be created. That's going to be created from the bed of your printer up to your part. And then we have a sampling distance. This is going to be the distance between each connector where it's going to connect on your overhang area. And we're going to set that to 0.25. And the connector diameter is the diameter of the point where it actually touches your mesh. So we're going to set that to 0.1. The connector height, which is the height of the connector between the overhang and the first joint in the structure, we're going to set that to 0.5. And the base diameter, base height, at the base of every one of these structures on the printer bed, it's going to create a base diameter and a base height as a foundation to hold this structure. So let's go ahead and close that. And also one thing I wanted to note on the base connectors on mesh, what that means is sometimes if the algorithm, when it determines the support structure, it may need, some of the base connectors may need to go through the part to get to the bed of the printer. Now you can minimize this. You can set this to minimize. You can allow them or you can disallow them. If you disallow them, then the algorithm will have to figure out another way to get around it, your mesh, in order to get to the printer bed. For now, we'll just pick the minimize option. Now we'll go to the support generation tab of the dialog, and you have two generation types. You have a tree type and a straight type. Let's do the tree type first, and we'll show you what that looks like, and then we'll pick generate. So now what you see here, let's turn the printer volume off so you can see a little bit better. Roll this up a little bit. The blue area is our overhang. That's our 45-degree angle. So it calculated all of the overhang areas on your part, and it developed a support structure that started from your sampling points, your sampling distance that you entered, on your support structure, and it grew a structure that goes from those points when it works its way down to the printer bed. And this is your base diameter and your base height. So that's really cool. Now, if you want to see what the straight structure looks like, we can select that and generate. And you'll see that with that option, it just goes straight down from each connector to the bed. Now, this will use more printing material. I happen to like the tree structure because it looks good and it saves material. So let's pick generate. Now, another neat feature on this dialog, again, we're going a little bit outside the PDF version of this, but I just wanted to show you this while we're in here. You can add and remove support structures manually at this point. Let's say you thought it had too many supports here. You can go in and you can delete a support. You can just pick them and they'll be removed. So there's no more supports at those sampling points. If you want to add supports, you can pick the add button and you can add those back. You can even add more. You can add anywhere you want. And when you feel comfortable with the supports and you like the way they look, we can go ahead and get additional details on the support structure. Go down to this tab and it's going to calculate the volume, the printer material volume that's required for your support structure. It's going to calculate the total length, linear length that's required to create these support structures. And both of those look good. So let's go down to the Create Mesh tab. Now, here it gives you different options for actually creating the mesh. Currently, it's just a display support structure. It doesn't actually exist right now. It's just in the display. So we have to create it based on the parameters that we've selected. Now, you can choose to create a separate mesh object. In other words, there'll be another mesh in the data tree just for the support structure, or you can merge it with your part, and you can even create a separate mesh for each support tree. Now, we're going to leave it at just create a separate mesh. One of the benefits of that is later, if you come back in and you say you think you want to redo the support structure, you don't like it, you can just delete that mesh and redo another support structure. Let's leave it at created a separate mesh and let's create it. So here we have a second mesh was added to the data tree. That's our support structure. This is our part, and looks like we're ready to 3D print this part.